Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. For tonight, we're going to take a look at using the TI-Innovator Rover as a learning tool in the math classroom. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. I'm excited to be joined by our two panelists, Paul Alvis and Brad Poznansky. Paul is the department head of math at Fletcher's Meadows Secondary School in Brampton, Ontario. He is also serving his second term as president of the Ontario Association for Mathematics Education. Paul is a frequent presenter at local and national conferences and has been a T-Cube national instructor since the year the first iPhone was introduced. Also an avid user of technology in the classroom and is especially interested in trying to embed coding as a vehicle to improve mathematical understanding. Paul, it's great to have you with us.
Thanks, Mike, and welcome everybody. I hope we have a great hour together, and I hope you get a lot of great interaction, a lot of learning happening in the next hour and a bit. Welcome everyone.
And Brad is in his 23rd year of teaching at Comswoog High School. Brad, you're going to have to help me with that one. I did not do that right, but I apologize. And I know, Brad, you've been using TI technology in the classroom ever since you student taught. You're a firm believer that you never stop learning, and that's evident in your pursuit of new and innovative challenges made possible through TI technology. Brad's presented at local, state, and national and international conferences, and he coaches 3 varsity sports and loves to sail in the Caribbean. Brad, it's great to have you with us.
Thanks for having me, Mike, and that's Comswoog High School. It's a tough one.
That was going to be my fourth guess. I was almost there. We're expecting a lot of people to join us tonight, so your audio is muted. Feel free at any time to send any questions that you may have for Brad or Paul using the Q&A window on the right side of your screen. We'll also be using the chat window tonight to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Brad is going to discuss our agenda.
Our agenda tonight is going to be talk about coding resources that are available, the 10 minutes of code, and some of the on-demand webinars that are available from TI. This is a nice kickoff before the Computer Science Week, which starts next Monday, so that's a nice little send-off for us. We're going to be discussing coding with the Rover and how to integrate it into your lessons in your math classroom. And tonight we're very fortunate because we're going to be having a webinar drawing for one lucky attendee to become a free, I guess they get a free, what's that called?
Registration?
Registration, thank you.
There you go.
Free registration, that's right, we're a team. Free registration for the international conference, the T-Cubes International Conference in Dallas next March. So we're going to have one lucky winner tonight.
Thanks so much. And Paul is going to discuss our expected outcomes.
So the outcomes for tonight, you can see them up there, but I think sometimes when we look at the Rover, we kind of we just see the possibilities of what it can draw and all that, but we want to kind of capitalize on what it can do and what we can do with it in the math classroom. So we're hopefully going to try to draw out and elicit some new ideas on how we can use the Rover in the math classroom. And then also there's some stuff out there already, and so how can we expand on what's out there already, and what else can we get out of those activities? How much more can we draw out of those activities and connections we can make to content we have in the various subjects we teach?
Paul, thanks so much. Brad, you should have control. Feel free to share your screen.
Hey, great. Welcome, everybody. Should be coming up full screen. Go. All right. So tonight as Paul just said, we're going to try to see how we can get this rover to be part of your classroom and part of your teaching of math. Um, so we did have our expected outcomes. All right. There's some stuff that we're going to show you that is already pre-made. So that way, depending upon what your entry level is to the rover, if you're an experienced rover user, if it's the first time seeing this technology, to get you guys excited about using this with your classroom and your students. So one thing that we do want to encourage is we're going to try to have you guys, ask some questions and participate in the chat room. So that way we can have a little bit more interactive between you guys, so the questions you might have or the contributions you might also have. Paul?
Thanks, Brad. And maybe just maybe touching on the initial slide with our contact, and if there's something that you like questions and follow up, obviously, just you can try to connect to us through Twitter as well, and you can see. Thanks, Brad. Maybe putting our Twitter handles up there, so um, maybe if you message us through that way. So if there's something you want to expand on, something that we covered too quickly, or maybe an activity or an idea that you want to share or kind of bounce off us, please, we're here to help and hopefully get as much out of this as possible. So the so I come to coding. I remember the last coding course I took was in second year, and I think we were coding and touring, and so ever since then, what I've kind of experienced in terms of coding has been self-taught, and so Brad, I think, has some really good coding chops. So he as you saw in his bio. So I think when I kind of thought about, okay, why would I want to code in the math classroom? I saw and I started to see some advantages. So we were curious to hear from you. Why code in the math classroom? What types of things do you think? What could it add to your teaching in the math classroom? So if you can go to the chat pod, and I see some people are already typing hello from north of Portugal. Wow, I was born in Portugal, so that's kind of cool. We have some representation from Europe. That's awesome. So if you don't mind putting in the chat pod your response to why code in the math classroom, what do you see as some of the benefits to students and to your teaching in the math classroom? Maybe while you're doing that, I'll just mention Mitchell Resnick, the quote that we posted there in the slideshow. He's the inventor of Scratch from MIT, and kind of one of the founding fathers of coding in the classroom and seeing its benefits to students, not only in the math classroom, but in a variety of different subject areas. I'll just give you a chance to put in what you think are some of the advantages or some of the benefits to students to coding.
And Paul, just to pick up on what you're talking about with this, coding in the classroom, I think it gives us also an opportunity for students to create things. I mean, I know in the elementary and maybe middle school levels, they're a little bit more, they're doing some creative things. And a lot of times in the secondary level, for me in the high school, it's, very much, task-based as far as answering questions and trying to perform that way, where here it gives them an outlet to be creative and try new things and get excited about different topics. Get any comments for our why code yet?
Great comment. I think that is probably from Claire. Probably not only true of as a geometry teacher. I would hope that you could probably make that claim as a teacher of, say, Algebra 1, Algebra 2, so on and so forth. The thinking, and that, I think that's the key word for me, is the thinking and the logic needed for proofs. Great point, Brian. Same basic logic that governs all math. So there seems to be a common thread coming up in just a few of the first initial comments. This idea of making the thinking explicit, connecting it to problem solving, um, getting excited about technology and learning to code. Thanks, Shannon. Great point. Wow, logic is key to everything. Thank you. Great point from, I think that was Gretchen. Thank you. Real world connections. And I hope that as we kind of go through the remainder of our time together, you'll kind of see some of the activities and some connections that you can make there. Self-instant evaluation. That's awesome. Love that. Thanks, Tim. A different mindset. All right.
In planning for this, Paul and I, we batted around some ideas, and these are some of the ones we came up with. And one of the things that I always encounter with colleagues and sometimes teachers is that they don't have time for it. And I understand that we all have mandated curriculums, whether it's a state mandated or a regional mandated curriculum that we have to get through. And I feel that if you do take the time to do it, it has far-reaching benefits than just a one-off activity. So I think there's ways of integrating it, and hopefully we can give you a couple ideas today with this. We talked about initially problem solving, right? You create a problem for them, and they have a chance to solve a problem as it is. Abstract ideas are now made concrete. Paul came up with that one. I thought it was a real good one. One that I've experienced in my classroom doing this is the proofreading. That is, the students, if a code doesn't work, it just won't work. So they have to find out why. And I've shared student screens with the class, and immediately you'll have some students that have just eagle eyes, and they'll say, you're missing a comma, or you didn't close that parenthesis. And so those are the nice ideas as far as, again, it is problem solving, it is proofreading, because that way, they want it to work.
I think Tim's kind of echoed that, and we had the comment earlier about instant self-evaluation from another different Tim. That idea of that instant feedback that when you run a program and you run your code and it doesn't do what you anticipate, rarely does that happen in math classroom unless you flip to the back of the book and you kind of check your answer, and sometimes even then you don't have an idea of exactly what went wrong. But with code, it's right there in front of you. So why didn't it do what you expected it to do? And I think Brad and I were talking about this as well, is kids are more sometimes in math class they're reluctant to share errors when it's kind of devoid of code, when it's separated from code. But in coding, they readily share, hey, why didn't this work? And they're talking to their neighbors and their peers, and they're trading ideas, and they're figuring out what exactly happened and why didn't they get what they were anticipating. And
just looking down at the last one with fun is, I can't tell you the number of times I've seen a student with a big smile or an excited expression when something, first of all, just they drove the rover and made it happen, or they completed a task or a drawing that they made with it, and they were so excited that they created it. So I think, we can't, forget about there's a little bit of fun involved with this.
Absolutely. There's that engagement piece, and maybe just the one thing I'm going to highlight as well is, I think Wade mentioned it, and this is a big thing for me, is the idea that, and it comes back to the quote from Resnick, is this idea of coding to learn, that it reinforces what we're trying to do in the classroom. If you can code it, you know it. And so that's something I constantly say in the classroom. If you code it, you know it. And that idea of computational literacy, that if you can put it into a set of instructions, you really have a deep understanding of the content.
So, this is what a classroom can look like. Why code in the math classroom? Look at that, the engagement of the students already. This is Paul's classroom, and mine looks very much, same, where kids are on the floor, they're actively engaged in what they're doing. And, we're just going to share a couple ideas where we'll come back to some of these, but, they're being creative and, coming up with some,
Hmm.
whether it's a design. Here they created, an elephant. And Paul talked about this one right here.
Yeah, so this was I was doing a workshop in the summer, and a young guy was there was, I don't know what it was in this one particular group. They were just captivated by the Russian national anthem and things Russian, and so we were using the innovator for a bit, and so he programmed in the Russian national anthem, and then he recorded it with his phone, and then of course with the rover he decided that he was going to draw the hammer and sickle, and so yeah, rested his phone on top of the rover, and then he hit enter to hopefully try to coordinate the whole thing. So that there's that engagement piece that Brad was talking about again. That students, once they get something stuck in their heads and they want to try to get it to work, they are really deeply involved in it.
And so just one thing we're going to bring up here, before, and then we'll get into some of the activities, is, depending upon your level, on the TI website, the activities, this is just a quick little place to find some of their pre-made activities. So you could just follow along step by step. You don't have to be able to create anything on your own. And this will get you a nice little background and a little bit of a foundation in the coding. This is a couple of places that you can go, TI codes, and then the innovator lessons is where you'd find some of the rover activities. And then there's also a math in motion where there's constantly putting up new activities and ideas here as well. So just wanted to point these out so that way you have a place and a resource center for you guys to check out or to use in your classrooms as well.
Yeah, you definitely don't have to start from scratch when you're when you're trying to embed the rover into your classroom. And just so we have a lot of people online, and we might not have we might have a variety of different uh, expertise in terms of coding, and some people have never coded possibly before, whereas you might have some very experienced programmers in the group. One thing that I like to do with my students is, and sometimes I'll do this on a regular basis, is a sort and sequence. So I'll have written. So this is an example from. So again, I teach in Ontario. Uh, um, of a code in the grade 11 program, we were doing some finance math, and even though the calculator does have the TVM or finance solver in it, I think it's still an opportunity to give them some coding, and again, to learn the math better. And so I just print out a short. I don't make it too long because I don't want to be cutting up too much stuff, but I print the code and cut it up into small little bits. And so their task in groups is to try to sequence it. Once they sequence it, enter it into the calculator. If it doesn't run, as we mentioned before, that's a part of the learning too. Why didn't it run? But if it does run, then they know that they've kind of have a good understanding not only of the math, but also of that computational proficiency and literacy. And like, you can do that with anything. I had a factor program that I did the same thing with. So if you're just getting your kids introduced into coding, every once in a while, it's not a bad idea to just kind of use something where they don't have to code from scratch. They can kind of use something that's been pre-created.
So just to get you guys up and running on a program, this is not going to be us showing you how to do it with the calculators, whether it's the 84 or the Inspire. They both will achieve the same output with the rover when they connect to it. But these are just a couple quick and easy ways of starting up your documents and your programs for your calculators and your rover. So each platform, you're going to have to create a new document or a program, depending upon which one you're using. And this is really the quick start piece here to driving the rover. Is you have to get the code in there for the hub, which sends the information to the rover itself, and some of the code as far as driving it, and there's drive commands. So it's very menu driven, all right. So it's not like you have to be able to type all this in, and you'd be following along that way. And this is what a basic program would look like on both the 84 on the left and on the Inspire on the right. So, and in this basic program, both of them say connect to RV, so that's going to turn on the rover. Just kind of like we tell the students, you have to start the car, you have to turn the key. So that first command there, as far as connect RV, that's connecting the rover to the calculator. And then the first code there is setting the rover forward 5 units. Now, the one thing that I do want to bring up is with the units, all right, we'll give you the default distance. 1 unit is, I believe it's 10 centimeters.
Yeah, it's a decimeter for all our metric friends.
Okay, yes, right,
Yes.
north of the border. And so we encourage, depending upon how much real estate you have in your classroom, keep those, those numbers maybe to 5 or less as far as how many units you're going to go forward, just because if they put down 50, it's just going to start running right out the classroom door. So keep them small to start with as far as how many units forward it's going to go.
Yeah.
And again, it'd be ideal if you had a classroom full of 25 rovers, but in the real world, you might have to share a little bit. So there's going to be a little bit of interaction between the students, all right, and a little collaboration. So that's always a good thing. So with our first activity here is a parallel parking activity. And so we're curious, how would you see, some math involved in this particular activity in your classroom?
Yeah, so if you don't mind in the chat pod, and just to piggyback on some of the things that Brad is mentioning while maybe you're typing in the pod, like what math you think that would be involved in trying to get this activity to work with the rover, what types of math would the students be needing to draw upon. Again, when you're introducing the rover into the classroom, as teachers, a lot of our programming most likely will be done in the software. Like for example, the sequence and sort activity, I type that into the software and print it out and cut it up. But also that idea of getting the kids just used to the way the rover moves. Sometimes I just write a quick little program with a series of drive commands where they just observe the rover moving, and then they take a look at the code and they try to deconstruct what is that language, what do those commands mean to the rover. So for example, drive 5, and so they try to figure out what is that default setting for the rover. You can reset that if you want, but the rover is default. The default distance is a single decimeter. Right. So Jennifer, angles or rotations, good, and proximity of other objects, excellent. So Natalia there.
Now, one thing that was brought up to me here is, depending upon where you live, some students might not know anything about parallel parking. I've found out. So I thought that was kind of an interesting topic as well. Me living in New York, there's definitely some parallel parking involved on the streets. So, and the reason why I brought it up is because nowadays, apparently you can press a button on these cars and they'll parallel park for you. So that was all news to me. I don't happen to own any of these vehicles, so I have to do it the old-fashioned way. But you can make that connection with the students as far as, someone had to program these cars to do just that. So, it gives them an opportunity to think of, where coding could go and, what's involved with it. So here we have, a little mathematical overlay of our parallel parking as far as the angles that are going to be needed for the rover to get into those, that little tight little space there. So, it's going to involve probably going backwards, and then probably a little bit of a turn of the car, and then, another turn going forward. So as far as that's usually an intro activity that I use in my classroom, as far as kind of giving the students a little bit of a license to drive with the rover before they get, loose on any other activities. And what's interesting too, geometry. Yeah, that's right, Kev. I saw, nice little application of some geometry that's, involved. And, so the nice thing about seeing the students, you don't have to have any high-tech, cars. You could put a couple plastic cups out there and let the students, drive between the two of them. And my video is not working right now, but what wound up happening in this slide here, these students, what's nice about this is that they wound up crashing a couple times, and as Paul was saying, the students, it's a mistake. They don't mind making those mistakes. They corrected it, and they were able to successfully navigate between, there it goes. See what happens.
Yeah, it's a little choppy, but it's coming through. At least on my end, it is. Oh, just bumped.
Yeah, no, just bumped that. Yeah, so that was one, and then here they actually won successfully. So, that trials and errors that the students go through as far as getting the rover in those places. I've actually had some creative parallel parking where somehow they went straight into the spot and spun the car sideways. And then I told them, their cars don't necessarily work that way. So it was kind of some interesting solutions and some, restrictions that you have to put on them as well.
Mm-hmm. Now, what we're gonna try to go through a variety of different activities where we've used the rover in our own classrooms. But again, hopefully this triggers some ideas for you, and we encourage you in the chat pod as we go through this. If something jumps to mind, please put it in there. We're here to collaborate and learn from you as well, not only to share some of the things that we've done. One of my favorite activities in our grade 9 curriculum here in Ontario is this idea of finding the sum of the angles in a polygon. I love doing it because it's got connections not only obviously to geometry, but there are some patterning connections and some algebra connections as well. So I try to get as much mileage out of this activity as possible. So the first thing I try to do with the students, and it's on the next slide, is I'll ask them to code to write a basic program, and this is something I like to do, and maybe another kind of maybe a teacher move here. So I mentioned the sequence and sort activity that I like to use for students as they get familiar with coding. But another thing that I like to do a lot with my code is I write the skeleton of the code to reduce the amount of button pushing that the students have to do, but I leave out the key components of the math. So, for example, this program, very short, is intended to display the sum of the angles in a polygon based on what the user puts in as to the number of sides. And so before this activity, the students, we usually do an investigation with paper and pencil. So I actually give each group a variety of different polygons, and then I try to also tell them, other than the rovers, no other technology. But because I found sometimes students would just Google the answer. I thought, well, not much learning happening there. But let's try to kind of build up to that understanding. So they come up with that idea of there's a connection between the number of sides and the sum of the angles in that polygon, and some of them will relate it to the number of triangles I can draw in it, but some of them will relate it to they draw the number of triangles are connected to the center of the polygon, which is kind of interesting and different. And so you've got groups doing two different things. And then the next step with that is, okay, once you've built that relationship, let's see if you can kind of confirm it using some code. And so I get them to complete this program with the math part in here. So the variable that they're going to have to figure out to calculate is S. So what is the statement that's required to evaluate and determine S, the sum of the angles in the polygon that the user would like to determine? And so And so then that's great. Now, one of the offshoots of this is, of course, you'll have one student who is going to say, "Oh, what if I put in something like 0 or -3?" And so that's a great kind of point. So, yeah, okay, how could we restrict the user and remind the user that we want only values greater than or equal to 3? So then that starts to bring in ideas of making our code a little bit more sophisticated and adding in conditional statements. So then we can kind of take it down into, okay, if the user enters a value that is less than 3, well, then maybe we should ask the user, you can't have a polygon with that many sides. Try that again. So it's a kind of a neat activity that leads to a lot more, and again, a little bit more coding sophistication from something that started very simple. Now, once we kind of get past that, if we want to move on to the next slide, Brad, the next thing is, okay, what we want. So the code there is that little program that I just mentioned has nothing to do with Rover. They're not drawing anything. It's just this idea of kind of the comment that was made earlier about reinforcing and consolidating the math that they already know. Again, if you can code it, you know it. So now it's okay. What if the user wants you to draw it? What if they want you to draw the polygon that they want? And so one thing you can have the students do is say, okay, let's draw a square. And so you might see a sequence of commands that looks something like what you see on the screen there. So again, you've always got the connect RV command to, as Rad said, turns the key on, and then move it forward to left and so on and so forth. Now, the next challenge to the students, and I'm going to pass it over to my partner Brad here, is what if we say, okay, that's great, everybody had success, they could draw a square. What if I want a triangle? So, Brad, what would they do in that case?
Okay, so just picking up just from this one thing, this one example as far as the square is concerned. The square is very straightforward, no pun intended, but you have forward and left, and they have to do these various commands. But then we present them with having to draw an equilateral triangle. And so this activity is really where some of the there's definitely some teachable moments here. There's definitely some trials and errors that are going to occur. And so if we put it out to the participants tonight, what do you think the code would be? Obviously, we're going to be driving straight, and then we have to make a left turn. So how many degrees would we have to turn in order to get this an equilateral triangle?
Yeah, maybe try to think of, like I think of some of the things that we talk about with Smith and Stein's work about anticipating student responses. What do you anticipate students would give you? And so I see Gretchen put in 60, Eduardo 120, obrigado, 300 degrees from Jennifer.
And so with Gretchen's comment of 60, that's going to be definitely, it's the interior angles there are 60 degrees. Kim says 120. So, I think there's a relationship between the 60 and the 120 there, Paul. So picking up a little bit there. Now, the one thing to keep in mind is when you're sending the RV, and so this is that sample of the code, it's send RV left, and then there'll be a space, and you're able to enter the number of degrees in which the rover will turn. And so, we're all thinking about that interior, well, not all of us, but you think of the students will be thinking about that interior angle, and what winds up happening is it's not the interior angle that is actually turning. It's turning that exterior angle. If you're creating a polygon, but that's the angle that it's going to be turning. So if they put in 60 and they do that 3 times, they have a shape that just does not connect to where they started. So it's a great opportunity for the students to make a mistake, and inevitably they all pretty much make that mistake the first time around. And it's amazing how the students, they don't look to you and say, well, what do I need to do? They just grab the calculator and they start putting new numbers in there and they're like, oh, it's got to go more. It's got to go more. And some of them will say, oh, wait a minute, it should have been 120. But the majority of them will go, okay, well, let's make it, 80 degrees. Let's make it, 100 degrees. And then they sort of come to that realization there. So it's a real nice opportunity for the students to make a mistake. Some of them kind of laugh at themselves and they're like, oh, yeah, I got it now. And so then they start thinking about how the rover actually turns when you give it a certain number of degrees for a turn. So it was one of my favorite pieces as they started. So, and then, one of the things with this, we're building up to these regular polygons is a lot of times my colleagues are like, oh, they're just putting stuff into a calculator. But here, and Paul has in his classroom as well, they grab a pen or a pencil and they grab either a pad or they have these whiteboards and they're just writing down their thoughts and they're calculating and trying to figure things out. And obviously, the one on the left-hand side, you can see they're actually saying how many degrees they're going to go left and what direction, another right turn, and how far they're going to go to draw this bow tie figure on the board. So it's always neat because you could start seeing them thinking, and even with their hand motion, you could see them kind of thinking out loud in their applications. And here, we're talking about what their code's going to be, and they're writing it down and planning for it, whether it's correct or incorrect. But that's where they're making their mistakes or they're making their discoveries. So, and this is the code for that triangle, right, where it's going to be forward a certain distance, and you're going to make a left turn of 120 degrees. And so what happens here, though, is, triangle has three sides, but then when we start bumping it up to, let's say, a pentagon or a hexagon, students, they get tired of putting these commands in there for a while, and they're looking for a way of maybe simplifying the code that they're writing, and so it naturally lends itself to loops, and so which is nice because it's almost like they're demanding a more efficient way of coding this into their calculators. So I always thought that's kind of a nice little piece there where they're thinking about efficiency in their coding. So we're leading up to, I know this was covered by Michelle Reinhardt and Tony Norell several months ago with the intro to the rover. So what we came up with is, and it was alluded to in that session but not covered, is how can we make the program to do any polygon, like an n gun, or any regular polygon? What input are we going to need? How many sides and the angles? Are we just going to require the number of sides? Are there multiple ways of doing this particular code? And I like that multiple, we talk about multiple representations in math a lot. We could also talk about multiple ways of coding the same task. So looking for some input from you guys as far as, what are we going to need in order to, as an input for this program?
So, and I like this. So again, the trajectory, this is why I love this task so much is, so the trajectory goes from, we talk about low floor, high ceiling, but also there's a low floor, high ceiling with the code here. So you start with, like as Brad kind of mentioned, like the students kind of, turn left this many degrees. And so then they say, okay, I'm going to draw a triangle. I'm going to need 3 of those commands and 3 drive commands, and boom, I've created a 3-sided figure. But now the higher ceiling is, what if we generalize that and say, I want to create any number of sides? And so this was quite honestly, so I did this activity in the summer with a group of students, and this just naturally came up. It organically came up and said, okay, we want the user to be able to dictate the number of sides. We want the user to state, I want to draw, whether it's a 3-sided figure up to whatever it might be. And then the code has to reflect or be adjusted in such a way that will generate that. what exactly? So then again, they got to think. And so one thing that I try to do, again, maybe another teacher move that I like is sometimes when I have students writing code for the first time, I have them create the pseudo code, which is basically don't like Brad showed you pictures of the kids. They're writing still. They're recording their thinking. So what I ask them to do is try to write down what you think are the sequence of steps. It's not necessarily explicitly the code that you're inputting into the calculator. It's this is what I think I want from the user. This is what I think I want the code to do with what the user provides me, and this is what I think I want the rover to do. So they kind of plan it out, and again, it gets back to what someone mentioned earlier, that idea of sequence of planning and thinking logically about the sequence of steps, and then they specifically break down each of those pieces and write the specific code within the device. So like going back to this activity, so the user will basically just provide the number of sides. I want an eight-sided regular-sided octagon or whatever it might be, and then the code the that the students have to write will. And oh, sorry, the other thing that we also decided as a group when we did the activity was the user should also input the length of the side for the regular polygon as well. So there were two inputs that we wanted from the user, and then from that the code moved the rover the inputted length, but also now calculate the appropriate interior angle. And as Brad said, that's where the math came in. And I remember when we first did this, I did it with another group where we didn't even do the initial stuff, and I just said, here's what I want you to do. And some of them, I said, test it with a triangle, and some of them got half of a hexagon. And I said, okay, obviously that didn't work. So look at your code and try to understand, be the rover. Understand you are that machine. If you are following step by step those instructions, why are you producing that drawing? And if you can understand what the machine understands, you should understand why it's not giving you what you want. And so they quickly figured out that they're drawing they're drawing the supplement to the angle they actually wanted. And so then they quickly made an adjustment in their code. Yeah, there it is. Thanks, Brad.
Yeah. So with the code that, the students, I was proud of the fact that they readily came up with this, and they did have to, think about, well, how many degrees and different, polygons and interior degrees, and then dividing it by the number of sides. So within this, it was, there's the math involved in it. And again, if you wanted to, you could give them some of this, as Paul had done, a shell where you had that loop already set up for them, and they're really working on the, the 180 minus the 180 times n minus 2 piece. And what came out of this, which was interesting, and sometimes you just discover some new things, was it lended itself to like, well, how else could we, have done this? I mean, that looks kind of clunky, that 180 minus that, fraction and storing it as a variable. And so I discovered, I didn't even think about it, was if we simplified that top expression, we get just 360 divided by n, which is, I believe that's the exterior angle formula for any, n gun. And so, here we have here's some math, it's as far as not just the geometry aspect of it, but, if you have an algebra class and we're simplifying an expression, all right, they don't necessarily need to be doing exterior angles, but again, an opportunity to kind of, do some other math involved with this as well. So that was, kind of a neat little moment that, they can maybe make it a little bit more elegant, a little bit cleaner than the top expression. So, but again, this is them coming up with these regular polygons, and it was nice application for them as far as, this was concerned. So, if you guys have any thoughts or comments on that particular topic or that task, we'd love to hear them in the chat room. Where you could go with this. I mean, our aim is to give you guys inspiration, give you guys ideas and thoughts that we would even think of that you could, go back to your classroom. And Michael's going to be in the file that's included with this, or the folder for this webinar. I have the code for both of the Nspire and the 84 for the regular polygons. I didn't do the parallel parking, but the next couple activities that we're going to do, I had those included as well. So if you just want to, you download those and put them into your calculator, running right away.
Yeah, and yeah, we've we've each tried to give you as much content as possible. So I've also included the Polygon activity that I mentioned, and again, within the code, you'll see again, one of the things I like to do is I leave out pieces, and sometimes you'll see little question marks, and that's a signal to the students that okay, that's I got to add the math in there. And I'll try to use a lot of comments in my code to signal to the students that what each chunk of the code does, but also, hey, I'd like you to do this in the next line, so that they're kind of directed to what to do.
So this next activity, which is brand new, we just came up with it. And I'll discuss what this command is on the rover, and 2xy, and it might be self-explanatory, but it's going to send the rover to a coordinate. So if you request, you say 2xy, and then you put 8 space 5 in the code, the rover will drive to the point 8, 5. And one of the things that it blew me away the first time I saw this, I expected the rover to drive forward 8, make a left turn, and then drive forward 5 units. And lo and behold, as soon as I pressed enter, it turned and drove right to the point 8, 5. And so I started thinking to myself, wow, I've been graphing points for years, and I always counted over or counted up, and this went right to it, which I thought was kind of neat. And so it got me thinking about, well, we had this command 2xy, but how can we leverage that to bring some more math into this? And so I decided to pretend that command was broken, and we had to program the calculator or the rover to actually be able to do it without that command. So on a very basic level, yes, you could have the students just drive forward and make a left turn and drive forward again for a certain number of units. And that would be initially, but then if the students did that, I said, well, how about if you're only allowed to use one forward command? How would you go about achieving this? And so they start looking at it and say, well, it has to turn a certain angle and it has to do a certain distance. So now that became the really driving force behind this little activity. And so it was pretty interesting. Some of the students that I was working with, they were Algebra 2 students, and they started coming up with the idea of using the inverse tangent, right? So they had some experience with doing some trigonometry, some basic right triangle trigonometry, and some Pythagorean theorem to take this to the exact point. And so whenever I do an activity, especially something like this, that was kind of neat. It's like, okay, we'll go to the point 8, 5. That'd be great. And then I started thinking, well, if we put any coordinate, whether it's positive or negative values for the x or y, it's got to go to those particular places. So, which brought in a whole new challenge as far as getting to the second, third, or fourth quadrants. So when I was thinking about that, it's like I didn't include that here, but it became, an extension of this particular task. All right. So, and both these codes, both as in the 84 and the Nspire, definitely will be in the folder as far as if you guys just want to grab it and go, or if you want to, have something to play with and practice. Now, one thing to note, and Paul, reminded me of it earlier, is the rover, if you're going to use this 2xy, it needs to be lined up facing the positive x-axis, just like in this diagram. And the axle for the wheel would be in line with the y-axis. And you'd probably put the middle of the rover right on the x-axis. So that's how it's designed. It's always oriented towards the positive x-axis, and it always thinks when it starts this program that it's at the origin at the point 0, 0. And then it'll execute that command.
Yeah. As I mentioned, one of the early programs I use when the kids are just getting used to the rover is the Rover Basics program, and it includes a whole bunch of drive commands. And one of the things I get them to try to figure out is not only that default distance, but also try to figure out when you say to this point, what is the rover understand as it where it's starting from, and how is it oriented in terms of the axes. So there's always some math learning even in simple commands like that.
And here is that second or third or fourth quadrant type of example. And this just gave some of my students some challenge to be able to pull this off. And we just did it to the second quadrant, and it could introduce some if-then statements. We were talking about logic earlier. So this we would definitely start integrating that. And as you start developing your students' coding abilities, you could start deepening their profile of commands that they can use. So now this next activity was done earlier in a webinar series, and Mike's going to definitely let you guys know where you can find some of the archived Rover webinar files, and it was corralling the sheep. And in this activity, there's 3 sheep placed in the XY plane, and your rover has to drive a path around these sheep. And so there is a pre-canned program that you can use. And this just to show you guys, and again, we didn't expect everybody who came today to have seen the previous one, so I just definitely wanted to show you this program. And this is done using linear equations, right? So we could use the 2xy command. That might be nice and simple, depending upon if you wanted to use that. But what winds up happening is in the activity, corralling sheep, it's for the Nspire, and there's one called linear for the 84, and I have that on the following slide. You have to use linear equations to be able to draw the line around the sheep. And the one drawback is, or not drawback, but challenge is, you cannot use an undefined slope for this. So that's a nice little, challenge to the students to get back to the beginning of this whole activity. Here, as I said, the 84 program is linear. Again, we included that in the folder, and it'll be drawing a line around this. And so one of the nice things about this is you could just use little erasers, as I did here. You don't have to have sheep. You're going to find that the students sometimes have a runaway car, and it might run over the sheep. So they don't account for how wide the rover is. They think they could just skim by. In the code, you're going to be entering a slope and a y-intercept. And then also, where is it going to begin and where is it going to end as far as your x values? So that's always a neat little piece of math for the students to think about, whether it's Algebra 1 from there. So that activity. And from this slide, you can see, there's the calculations. The students are doing a lot of writing before they're even putting these in there to make sure that this rover can successfully move around the sheep and pen them in. That was that activity there.
Yeah.
Just want to show you guys that. Yeah, go ahead, Paul.
Again, I kind of I love this activity because, and I know one of our learning outcomes from tonight is this idea of trying to take an activity and see what else you can do with it. And so in the past, this activity was done as, and again, a low floor. You can just do it with the 2xy command, where the students just program in the appropriate coordinates to avoid the sheep. And they also have to factor in the width of the rover too, because the center of the rover is really the line that it's following. And so, but then I love that this also allows for more sophistication. And so for students who have been introduced to linear equations, they can try to program in the appropriate linear equation to with the appropriate restriction to get it to where it needs to go. So yeah, another example of a great activity. And then also, does it have to be in the first quadrant? What if we shifted things around too? What if the sheep were in different places? So lots of different possibilities and a lot of stuff that you can do with this and with this activity.
All right, this activity we're not going to go into depth on, but I just wanted to put it out there. It's a great activity. It's the Mars Rover project, and there's some supporting documents with this. And the rover has to navigate around this volcano on Mars. And so the nice thing about this activity is you can download this PDF of this actual image, and you can, if you have a big printer at school, or if you go to like a FedEx or some sort of printing store, you could print this and laminate it and have the students use that actual image. But the actual task is the students are provided with this as a scaled picture. And so they have to come up with the scaling coefficient to be able to actually drive the real map, right? So this actually is, this image is on just an 8.5 by 11 sheet of paper. And this one here is 36 by 36, the actual sheet. So they have to pretend that they're NASA engineers, and they have this rover, and they get one shot, and you can give them a couple shots if you want, to actually successfully navigate its way around this entire volcano. So this activity is kind of a neat activity as far as, giving the students a little bit of a, I guess a ratio and proportion type of activity, and to, pre-program the rover to see if it makes it around this volcano. I have a colleague of mine who's done this as almost like a final project with her students, and they got 2 chances to successfully to make it around the volcano. So it was kind of a neat activity for them. And at the bottom here, I included the bit.ly link because that map was like 170 megabytes. It couldn't be uploaded into the file. So if you go to that link at the bottom of this page, you can get that file and download it onto your computer and then print it out from there. So I just wanted to include that. I think we're almost out of time. I'm going to send it back to Michael here. So Paul, anything to add here?
No, again, I'd encourage you, if you do, I appreciate all the comments in the chat pod, and I encourage you that if you do have questions or requests, if there's something that or if you want to bounce off an idea, please do message us. We're here to help. We're progressing on our own learning journey in terms of trying to embed this and maximize what we can get out of this. Again, I think there's so much that you can do to engage students beyond kind of that traditional stand and deliver model, but also embed the coding in there and reinforce that math, but also build up their computational literacy. Thanks, everyone, for your attention tonight.
I appreciate it. Yes, thank you for coming.
Thanks so much, guys. Just a couple things I want to share during our wrap-up tonight. First, I know both Paul and Brad mentioned that we've done a few other rover webinars in the past, and so maybe you want to view those and see what other information you can get. So visit our website, education.ti.com. And under the Professional Development tab in the middle, go under Webinars at the bottom. And then look for our on-demand webinars. And if you browse that on-demand webinars, you can filter that in different ways. So, for instance, you could select a technology such as the TI-Innovator Rover. And then you can see the 3 previous webinars we've done that are specific to Rover. So please visit our website to learn a little more about some of those previous webinars we've done specific to Rover. We're excited that the T-Cubed International Conference is coming to Dallas this coming March. It's a great place to connect with other fellow educators. Again, visit our website to learn a little more about the T-Cubed International Conference. Earlier, Brad had mentioned that tonight we're giving away to one lucky winner a conference registration, and tonight's lucky winner is Louis Carano. So, Louis, congratulations. We'll be in touch over email in the next few days to give you a little more information, but we hope to see Louis as well as everyone else at the T-Cubed International Conference. To receive a certificate of attendance, go and click that link that just appeared in the chat window. Also listed is a link for the documents that Brad and Paul put together tonight, and there are a lot of them. So please visit that documents link as well. If either of these links aren't working for any reason, hang tight in your email. You'll get a message in a couple days here, and that email will contain a link to the recording, a link to the certificate of attendance, as well as a link to the documents. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. So thanks so much, Brad and Paul, for everything you shared tonight. We really appreciate it.
Thanks, everyone.
Thank you, everybody.
Thanks to you, Mike, too, for playing host.
Thanks, everyone, for joining us. This concludes our 2019 webinar series, and we hope to see you back early in 2020. Have a great night, everyone, and we'll talk to you soon.